Yeah, we should be live. Should be working okay. I'll jump straight into it. We're trying to do this cochlear implant simulation. Currently, well, it says it's a cochlear implant simulator, but it's only an overview. It's showing the frequency amplitude. So like a spectrogram. This spectrogram is not over time. You can do something similar. No, spectrogram will be over time. The colors there, yeah, still mean intensity. I'm using a filter for my microphone that is being used for recording with the filter, but what you see on the screen is unfiltered. So if any noise or anything, you'll be able to see it here, including using the keyboard and the mouse and stuff. I don't know if you can potentially determine by which frequencies are activated, determine which mouse or key I'm pressing, so on and so forth. But we are not doing that. We're trying to do a cochlear simulation. So let's, AI alert. Let's read this.
This is a cochlear implant simulator. It is designed to help you understand how cochlear implants work. A cochlear implant is a device that can help people with severe hearing loss. It works by sending electrical signals to the brain. This application will help you understand how these signals are sent. To use this application, click the Start button. You will see a graph that shows the electrical signals being sent to the brain. You can adjust the frequency and amplitude of the signals using the sliders. You can also adjust the number of electrodes that are used to send the signals. Try different settings to see how they affect the signals. This application is for educational purposes only. It is not a substitute for professional medical advice. If you have questions about cochlear implants, please talk to your doctor or audiologist.
Right, so we have the disclaimer and everything. That's great, but technically wise, we need some sort of model of a cochlear implant electrode array, which normally has roughly 20 electrodes on it. And why are we talking to no one when we could be? Yeah, just one thing that I learned the hard way is that we shouldn't have any CSS files because we have one for the entire project. So then the background, the text, whatever the titles, things like that will be set by the CSS for the project. Within the HTML, we will be styling specific elements. So let's make sure we are not calling any CSS in this case. Yeah, I have to fix all my previous projects in the same way as well. Yeah, we wanna all the controllers, buttons, sliders to all look the same everywhere. And probably a good template would be the music converter. It's a bit heavy, don't know why it's loading for quite some time. But yeah, that's the one we want to be using as a template for the project, for the styling. The page, I mean, it's not ideal, still can improve it a lot, but it will essentially look something similar. Okay, so this Flask application, let's actually use the bot. I mean, ideally we'll be talking to a human who's interested in this kind of stuff, but because humans tend to be very busy or pretend being busy, then we have to use the robot. What was the Copilot was recommending something? No, something redundant. That's okay. HTML. we can. Yeah. So this supposedly what is Copilot is hallucinating. Say, mail to this application was created by Cochrane Plant Research Lab. No, it wasn't. Where it's getting this information from? So yeah, we can direct it in a different direction. Let's see. What do we want to do? We need some sort of model. A model of a cochlea implant electrode array. And let's see what it knows about. Where's the image from? we don't actually have it. Yeah, we need to create some sort of simple model. It could be similar to actually we're doing a game of life, so I'm jumping around, but it's a pixelated grid. I don't know how many pixels, like 100 by 100 or something. So we can actually draw it that way, and that will be handy because we could make a model that way. Using so it will be like what's that game that everyone plays? A display grid gap 1 pixel. Yeah, I'm not sure about that. It's not doing anything else, is it? The grid would be, where is the grid? Can't even see it. Can't even see the grid. I don't even know what it's. And why is this? Yeah, I can't see any grids. Control Shift C. There's nothing there. Create a grid of pixels. Class pixel. What? Okay, there are pixels. It's actually could be a good start for yeah, this could be electrode array. Yes, it's obviously taking your microphone stuff. That's not good. Styling. Get rid of that styling for a sec. on earth? Yeah, so that model. Yeah, each create a grid of pixels. Each, yeah, that's actually not a bad description. Wait, we'll take that description. Get rid of the rest. Create a grid of pixels. Each pixel represents an electrode in the cochlear implant. The color of the pixel represents electrical signals sent to the brain. Okay. The brightness of the color represents the amplitude of the signal. That sounds legit. The hue of the color represents the frequency of the signal. Well, the frequency of the signal would be, yeah, I'm not sure about that, but the grid is updated real-time signal being sent to the brain. The user can adjust the frequency and amplitude of the signals using a slider. Okay, we're using voice. Do you have anything else? No. Yeah, the hue of the color represents the frequency of the signal. I'm not sure about that. That should be bands. Frequency bands. So it should be band pass filters. Each lecture is a band pass filter that filters out frequencies that are too high, too low. Well, no. So it's almost there, but not quite. And let's go back to the original thing. Yeah, we need to do the description, but we can do it later. So we have the audio canvas, the start button. A creative grid of pixels. Will it be doing the code here? No. Yeah, this is actually it's amazing how I don't know where it's getting information from, but yes, this is better because before the sentence didn't sound right. H band was pass filter represent an electrode in the cochlear implant. The frequency of the filter represent the frequency of the electrical signal sent to maybe the amplitude. Okay, the filters are updated real time. No, the filters can remain. The filters are preset to represent the frequency and amplitude of signals sent to the brain. That's right. Create a graph to show the signal being sent to the brain. Okay, I thought that's the graph. Yeah, do we need anything over time? Okay, get rid of the time bit. Okay, we need the grid, that's for sure. A grid of pixels. Pixel canvas, okay. A filter canvas. We have the graph. We don't have the raw signal. Shows the audio signal being sent to the cochlear implant. The x-axis represent time. Okay. The y-axis represent the amplitude of the signal. Okay. The graph is updated in real time to show the audio signal being sent to the cochlear implant. Okay. I'm actually gonna do the code. Oops. Create a graph. Okay, we already covered that. Thinking, doing something, I don't know. How do you actually get it to... All right, that meant to be in JavaScript. That's right. Okay. A Ctrl Shift C. Yeah, we have the pixel, the filter. Okay. Okay, we have the one canvas. How many wait, how many JavaScripts we have? Okay, so we're using a module thing because it's that main JavaScript, and that should be okay. There's a setting. Is that settings doing anything at all? Don't think so. I haven't changed setting applied in my audio processing chain. Update frequency bands. Okay, we can get rid of the copy. We have settings main and audio processing. In main.js, are we calling another JS array? Come on. No, we're not. What we'll be calling audio processing from here. And change the settings applied to the audio processing chain. Yeah, don't like the structure. What is the structure anyway? We use Copilot with the workspace handle. Should have an info. Why don't we have... Wait, this should be called info text. Update. We need to update. Yeah, update that file and folder structure. We need to know what's what. A number of bands should define the number of band pass filters. Templates, okay, static. They have 3 JavaScript files. I'm not sure all of them. So audio processing is being used. Okay, let's bring in the big guns, the new model. Let's see what it can do. This is the main JavaScript for the project. Okay. And of main.js. Yes, I know this is not ideal, and we are not just using okay, we also have the audio processing, but I don't think we are calling it anywhere. I don't think audio processing frequencies. No, we will need it eventually. Visualize. Is this meant to be running independently or something? No. Yeah, let's start with this, see what it says. Okay. I can show you the game of life. It's an interesting game. It's like a weekend project. Yes, I am doing this full time, if you were wondering. So do go check out biomedical.com. Don't forget to turn your ad blockers off. There's a lot of interesting tools for you to try out, including some neural network trainer that it just shows you how unnecessarily complicated neural networks can be. You can change your parameters, training set size, number of hidden layers, noise level. Every time you change the noise level, you actually have to hit the retrain button. Sweet. That's a bit weird. Something isn't right. Have to check that tool. Yeah, now the noise went away. yeah, so it tells you if it converged or not. So yeah, if you reduce the noise in the signal, increase the set size, the training set size, it converges better on to the actual waveform. So go check it out. Let me know what you think. Okay, back to this. Oh, generating a lot of code. Sometimes it's being lazy. Let's read this quickly.
Your code provides a solid foundation for a cochlear implant simulator web application. Here are a few improvements and clarifications. Your Flask setup is fine. Ensure your HTML files are in the templates folder and JavaScript files in the static folder.
Isn't that the same?
Ensure your index HTML file is properly structured and linked to the JavaScript files.
Yeah, the size. I don't know exactly what the changes it made, but we will go for it.
These adjustments should enhance the functionality and maintainability of your cochlear implant simulator application. Let me know if you need further tweaks or additions.
No, that doesn't make sense. Yeah, we just want to explain the code. We don't want GPT-4 to actually code. We'll get Copilot to do it. It's insisting. Yeah, I don't like it today. It's sometimes it's too lazy and it won't generate any code, and other times, like now, it's just overly keen on generating code. Using Copilot.
This script handles the setup and connection of audio nodes. Setup audio nodes initializes the audio filters, compresses, envelope follows, and analyzes based on predefined frequencies. Connect audio nodes connects these nodes in the correct order for processing audio. Visualize continuously updates the visualization on the canvas based on the analyzer data. Create envelope follow creates an envelope follow using a wave shaper and low pass filter to track the amplitude of the audio signal. These scripts collectively create a web-based cochlear implant simulator, allowing users to visualize and interact with the audio signals processed by the simulated cochlear implant. Modular JavaScript files. The main logic is split into 3 files: main, JS, settings, JS, and audio processing, JS for better maintainability and separation of concerns. Code improvements. Updated draw function in main, JS to continuously update the canvas with the current frequency data. Implemented event listeners in settings, JS to dynamically update the frequency bands and compressor settings. Define setup audio nodes, connect audio nodes, and visualize functions in audio processing, JS to handle the initialization and connection of audio nodes, and to update the visualization. Helper functions. Added generate frequency bands, update filters, reconnect audio nodes, and update visualization in audio processing, JS for dynamic updates and better modularity. These updates ensure the JavaScript code is cleaner, more organized, and easier to maintain.